All right, well, for section 1.3, we're looking at story problems. And the book gives some advice on how to break these down. And this is fairly, you'll see this advice in a lot of different algebra books, or I've seen it before. And it's fairly good advice. So I'm just going to go over the 5 steps, and then we'll do some problems. So the first one is you want to reread the problem until you understand what's going on. Now, there's a way to test whether or not you understand what's going on. And it's basically you want to make 2 lists. What is known? What is it that we can see in this problem? What do we know about this problem? And then finally, what's unknown? What's missing? What are we not seeing? So the idea is to write a list of what is known and then write a list of what is unknown. And typically, out of the unknown list, there's some one quantity we're going to turn into a variable. I often call it X. Now, sometimes you might have 2 unknowns, but a lot of these problems, we're going to be labeling one as X. And then there'll be some other unknown quantity. We can describe that in terms of X. So that gets us to the second step. So we want to express other unknowns in terms of X. So we'll have a list of things for unknown, or for known, and they'll have a list of things for unknown. But there's going to be this one critical unknown that if we knew what that one was, we would suddenly be able to figure out all the other unknowns. They're all based on this one missing piece of information. So we can express them in terms of that key piece of information. Next, there's going to be some overarching relationship that's going to bring all this stuff together. And from that, we're going to come up with an equation. And that leads us to step 4. Solve the equation. So we're going to get some kind of answer. Finally, in step 5, we're going to check our answer in terms of the original wording of the problem. So we do want to check our calculations. We want to make sure we didn't accidentally put a decimal in the wrong place, those kinds of things. But we also want to check to see if our approach to begin with made sense. And one of the clues to that is what kind of answer did we get? If we're working, say, we're asking the question, I'm working at Subway, I'm making $10 an hour, I work for 8 hours, how much money do I make in that day? Well, if you get an answer like $8,000, that just seems way too much. If you're making $10 an hour and you're working 8 hours in a day, does it make sense to make $8,000? I guess if the people were really tipping well, but you want to look for those kinds of things. Also, if you get, say, your answer for the Subway question, you get 20 degrees, and you're like, how did I get degrees? That doesn't make sense. So sometimes your answer can tip you off to be, I think I did all my calculations right, didn't misplace a decimal or anything, but this answer just doesn't seem to make sense. Maybe I better go back and look at my approach. Like maybe I'm using the wrong type of equation here, or maybe when I did one of my expressions in terms of x, I didn't do it quite right. So I want to check for these things. One helpful hint is does our answer make sense? Do the units make sense? Do the magnitudes make sense? Is it positive? Is it negative? These kinds of things. So for example, let me give you kind of a simple problem. So let's say we have this. Let's say you make twice as much money per year than I do. So your salary is twice as big as mine. And let's say the total of our salaries is $90,000 a year. So how much money does each of us make? So let's think about this. You make twice as much as I do per year. And the total salaries, if you add mine plus yours, it's $90,000. So the sum is 90,000. We know that. We also know you make twice as much as I do. So that's what we know. But what do we not know? Well, we don't know each other's salaries. We don't know yours. And we don't know mine. But here's the thing. We know your salary. Yours isn't totally a mystery. We do know something about your salary. It's twice as much as mine. So even though yours is unknown, we don't know exactly what you make, it's not completely unknown. My salary, on the other hand, totally unknown. We just know that I have one. So this one here that's totally unknown, and yours is going to be based on mine. Yours is twice as much as mine. This one here, this is the real unknown. This is the big mystery. Let's call that X. Yours isn't totally a mystery, but mine, totally a mystery. We're going to call that one X. So let's come up with some expressions. Now we know that my salary is X. Now we also know that twice my salary is equal to yours because you make twice as much as I do. So let's come up with an expression in terms of X for your salary. So 2 times my salary equals your salary. And then let's replace this with X. So this is a multiplication here. I better use a dot, not to confuse it with the variable. So 2X is your salary. So we took the ultimate unknown, the thing we knew nothing about, and we called it X. And then the other unknown, your salary, which we kind of knew something about. Because we kind of knew something about it, we could describe it in terms of X. 2 times X. Now we need an equation. According to the problem, my salary plus yours is $90,000. So that's going to be a beginning of our equation. That's an overarching relationship. Now my salary is represented by X. Your salary by 2X. And the sum is $90,000. So now we have our equation. Let's solve it. So if we add the x's together, combine like terms, we get 3x. Divide both sides by 3, we'll get x, or my salary, is $30,000. Now we're not done. We need to find your salary. Now your salary is 2 times x, or 2 times 30,000, and that's $60,000. So we found the two salaries. Now let's check this. So these are the two salaries. So these are our answers. Do these answers make sense? Well, the problem originally was my salary is half of yours, and the sum of our salaries is $90,000. Find the two salaries. Well, let's start this off. My salary is half as yours. So let's convert that sentence. My salary of $30,000 is half of yours, which is $60,000. Well, that makes sense. 30,000 is half of 60,000. Second part of the problem. The sum of our salaries is $90,000. Well, the sum of my $30,000 salary and your $60,000 salary is $90,000. Does that make sense? Yeah, it does. That makes perfect sense. So it seems like these are good answers. So there we go. So that's the general approach to solving these problems. So let's take another problem. Let's say we have this. So let's say we have this, a shop charges a customer $448 for $63 of parts and the remainder is labor. So this is what we've got. You go to a car shop, you get your car fixed. The bill is $448. $63 of that is parts. The rest of it comes from labor. So if labor is $35 per hour, how many hours of labor did it take to fix the car? So $448 is the total. $63 comes from parts, and the rest of it's labor. And we know the labor is $35 per hour. So how many hours were used to fix the car? Well, let's take a look at our knowns and unknowns. So what do we know? Well, we know the total. $448. We know the parts. Is $63. And we know that labor is the rest of the cost. We know labor is going to take up the rest of the cost, and there's no other cost. Like there's no sales tax in here or anything like that. It's just parts, labor. That's it. We also know labor is $35 an hour. So what do we not know? Well, we don't know the cost for labor. We definitely don't know that, though it wouldn't be too difficult to figure out, actually. And we'll get to that. But what we're looking for, what they're asking us, and this is the big unknown, they want us to find out how long it took to fix the car. So what we really don't know is this one. This is the big thing. And we can get some idea what the cost of the labor is. I mean, the total is coming from parts and labor. Subtract parts from the total, you'll get the price of labor. This is going to be fairly easy to solve. This one, we don't have anything about that. That's just missing. So let's call that X. That's the big unknown. So now let's talk about expressions. So there's one thing that comes out here that you could put this in step 1, you could put it in step 2, but we can find out the cost for labor. That's fairly easy. There's an expression we can do here, and it doesn't involve X, but total is parts plus labor. And we could subtract the parts from total. And if we do that, and let's see here, let me grab a calculator really quick, pardon me. Give me for just a moment. I forgot to grab my calculator. Actually, I'm pull out a phone here. So you get 385. So for what it's worth, we can figure that out. But in step 2, we're really looking for expressions in terms of X. And what we're missing is the hours of labor. So how do we find the hours of labor? Well, we know the total for labor is 385. The labor cost well, that's going to be hours it's the hours of labor times the labor rate. This is something you're being charged, like the pay rate or the cost. Now we know the labor cost, the total cost for labor was 385. The hours of labor we don't know. That's X. But we are given the rate. Labor was $35 per hour. So this gives us some idea of an expression for X. We know that the total cost of labor, which we just figured out, just subtract the parts cost from the total, that's going to be based on how many hours it took to fix the car. And that's calculated taking the number of hours times the rate that we're charged for the labor. So this means 385 equals 35x. Now, this is a good relationship, and to be honest, it kind of does the equation also. If we go to step 3, this is going to be our equation. Working with this expression gives us the equation. They're going to be the same thing. So we just have to divide both sides by 35. Let's see what that gives us. We do that in our step 4. We get X is 11 hours. So does this make sense? Well, does it take 11 hours to fix the car? Well, that could be. I mean, it's not like 400 hours or -7 hours. You shouldn't have a negative time here. And probably thousands of hours wouldn't be appropriate. But then we can go back and check our calculations. We can do 11 times 35. We'll get 385. Take 385, and that's now our labor cost. Add it to the parts per cost, and well, we're going to get 448. So far, it looks like a good answer. Well, let's try another one. That one's a little peculiar because the expression turned out to be the expression we came up with in step 2 turned out to be an equation that would actually do all of our work for us. We didn't need to go anywhere beyond that. Sometimes that happens. Well, let's take a look at another one. Let's see here. So let's say this. You invest $8,000 and stop returning 12%. Returning 12% of your investment. So let's see. Oh, yeah. Let me go back. So part is in stock that returns 12%. So not the whole 8,000, just part of it. The rest, it looks like there's bad news. The rest you invested in a stock that suffered a 5% loss. So basically, in this first account, if you invested $100, say at the end of the year, you now had $112. You got 12% back. But in this other account, let's say you invested $100, you would come back at the end of the year and you would lose 5% or $5. So there'd only be $95 in that account. All right. So if the total income from investments. This is gains plus losses, is $620. Well, then how much did you invest in the 12%? And how much did you invest in 5%? So how much did you invest in each stock? So you've got $8,000. Some of it you put into stock that returned 12%, which was great. Some of that 8,000 was put into a stock that lost 5%. It's bad news. And at the end of the year, the total was $620. So you still made 620 bucks, but you probably made more than that here, and it was offset by losses here. But still, you came out on top, so that's good. So let's take a look at this in terms of knowns and unknowns. So what's known? Well, we know the total amount of money invested, $8,000. The total earnings was 620. We know one stock increased or returned 12%. We know the second stock lost 5%. So that's what we know. What do we not know? Well, what we don't know is how much was invested in each account. Let's check one last thing here. All right. So that's what we don't know. So this is a problem where you might come up with two unknowns. Now, what we could say is that Y is the amount in the 12%. We could say that, and we could say X is the amount in the 5%. We could do something like that. And we could. And what will happen if you do this, you're going to end up getting what's called a system of equations if you approach it this way. And that can be kind of complicated. There's a way of simplifying this. Let's let X be the amount in the 5%. Now we know that if we take the amount in the 5% and add it to the amount in the 12%, the total should be $8,000. So if X is in the 5%, then the rest of the money is in the 12%. So we could say this. We actually know something about the amount in the 12%. If we call this X, and we'll clean this up in step 2, we would automatically know how much was in Y. Let's go to step 2. So let's say these are our two unknowns. We'll go with that. We have two unknowns. Let's write some expressions. So we know the amount in the 12% is X, that's what we called it, and Y is the amount in the 5%. Now, because these two add up to 8,000, we can say this. The amount in the 5 plus the amount in the 12 is 8,000. Now, we can do ourselves a favor. Let's solve for Y. Subtract X on both sides. Y is 8,000 minus X. So what this lets us do, we can rewrite these in terms of one variable. So we can get rid of this Y. So we'll say X is the amount in 12%, and 8,000 minus X is the amount in the 5%. If we can reduce the number of unknowns in our problem, that's really going to help. We don't have to use a system of equations, which makes life easier. So, all right, we've done a little cleanup work here. Made life easier and was able to get rid of one of the unknowns. Now, there's some other expressions that we want to keep an eye on. The total income. We know the income from the 12% plus the income from the 5%, that came out to $620. So we need to express the income for each of these. Now, the income from the 12%, what that means is we take the 12% or 0.12 and we multiply it to the amount in that stock. In this case, it's going to be 8,000 minus X. So we get a 12% return. That means we take 12% of what you invested and you get that given to you. Of course, you keep what you already invested. It's going to be 0.12, 8,000 minus X. So this is money you earned from the 12% account. It's 12% of what you invested in it. So the more you invest, the more money you get. This one, though, we lost 5%. So this is negative. So this will be negative 0.05. Again, convert our percent to a decimal times the amount of money that was invested in that account. Ooh, did I get things mixed up? Ooh, I'm terribly sorry. I got this mixed up. I apologize. There we go. Sorry about that. Take a second to update your notes. The Y was the 12%. The X is the 5%. So this is okay. This is okay. There we go. Sorry about that. So the Y was the 12%. The X is the 5%. So these give us some useful expressions. This is the income from the 12%, and the income, it's really a loss, from the 5%. Now we're going to come up with our equation. It's basically staring us in the face. Income from the 12% plus the income to 5% comes out to 620. And we know what those two incomes are. So 0.12 times 8,000 minus X minus 0.05x equals 620. And so now we're going to solve. So let's see, 0.12 times 8,000. Let's do the calculation there. That'll be 960 minus 0.12x minus 0.05x is 620. Or 960. And minus 0.12, oh, this is, yeah, minus 0.12 minus 0.5 minus 0.17x equals 620. Subtract 960 from both sides. They get minus 340. Divide both sides by 0.17 or negative 0.17. And we get x is 2,000. So this is the amount in the 5% account. So we invested this in the 5% that lost. That's money that was lost. We lost 5%. So to find the amount in the 12% that earned money, we take 8,000, which is the total, subtract the 2,000, and we get 6,000. So those are the two answers we've got. To check these, well, they do add up to 8,000, which is something we want to see. And if we put them in terms of the problem, if you invest $2,000 in an account that loses 5%, and you invest $6,000 in an account that earns 12%, the total income on what the earnings are is 620. Well, that kind of makes sense. So let's think about this. If you invest $2,000 and you're going to lose 5%, okay, so there's going to be a negative number based on that 2,000. 5% negative, 12% positive. So the percent earnings is 12% versus a percent loss of 5%. So, all right, seems like we should be coming out on top overall. If we're winning 12% and only losing 5%, seems like we should be coming out on top. Now we need to figure something out though. Did we invest a ton of money into that loss and not very much into the gain? Or is it vice versa? Did we put a lot into that winning account or did we put not so much in the losing account? Well, we certainly put not as much in the losing account as we did in the winning account. And the winning account had a higher percentage effect, 12 versus 5, compared to this. So the answer makes sense. So let's go with it. So one other thing to mention in this section, they have you solve for variables in formulas. And the idea is this, is sometimes when you're given a formula, it's given in a very certain way. And typically with formulas, this is what happens. Like let's say we have A equals B plus C. So what this implies is that we're going to get a number for B, a number for C, and then we automatically get A. And this is how formulas work. So if we say let B equal 10 and C equal 20, well then A, which is B plus C, will be 10 plus 20, or 30. So when we're given B and C, we automatically figure out A. Now here's the problem though. Let's say they gave us this situation. find B. So what we do, we have our A is B plus C. It's now 30 is B plus 20. Subtract 20 from both sides, we'll get B equals 10. Just because we have a formula does not mean we're always going to get B and C first, and then A just pops out doing arithmetic. Sometimes we might get like A and C given, we have to use algebra to solve for B. But then someone might come along and say, you know, we're going to probably be solving for B the whole time. Let's make life easier in the future. Come up with a formula for B. So to do that, we're going to solve for B. So this is what we're going to do. We're going to treat A and C like they're numbers. Well, they actually are. They're just unknown numbers. But we're going to treat them, we're going to move them out of the way. We're going to use the rules of algebra to get A and C out of the way. And we're going to treat B as if it's the only variable. We're going to treat B as if it's the only variable. So A is B plus C. We want to get B by itself. So it means we need to cancel C. So if you're adding C, subtract C, it cancels. But again, once you do the one side, you got to do the other. And because these are variables, we don't know what they are though. So we can only go as far as A minus C. We'll do it sometime in the future. Then these cancel, just leaves B. So now if somebody tells us, well, let A be 30 and let C be 20, we have a formula for B, tells us that B is 10. So this is a very common thing. So let's do some examples. Let's solve for W. Well, that means we need to get rid of L. Now, L is multiply the W. So the opposite of multiplication is division. So if we're multiplying by L, divide by L. Well, what we do to one side, we do to the other. And when we do division, we write it as a fraction. A over L is equal to W. And that's it. Now let's take a look at another one. Let's say we have this. And let's say we want to solve for B. We want to solve for B. Well, again, we want to get B by itself. Now, one thing you can do is, since we're multiplying by 1/3, we can divide both sides by 1/3, and that's perfectly fine. And or you can think of this another way. You can multiply 1/3 by its reciprocal, which is 3, or 3 over 1. And that also makes the 1/3 go away. But whatever you do, what you do to one side, you have to do to the other. So I'm going to multiply by the reciprocal. So the reciprocal of a number is the flip of that number. And when you multiply a number by its reciprocal, it cancels. This is actually going to be 3 times 1 is 3. 1 times 3 is 3. We're going to get 3 over 3. And 3 over 3 is 1. And well, multiplying by 1 doesn't change anything. So this, in effect, cancels. So we'll get 3v over 1 is vh. And again, dividing by 1 doesn't do anything. We'll just call it this. And there we go. We need to divide by h. And we'll get 3v over h is equal to v. And there we go. Let's take a look at another one. Let's say we have this. And let's say we're going to solve for I. Well, one thing to notice with this, in each of the terms on this side, there's a capital I. So that means we can factor that out. So this will become I r plus little r equals V. Of course, when we distribute this big I, then we get our original expression. Now we need to get I by itself. So we have to divide this entire piece, because this entire piece is multiplied to I. When we do the one side, we do the other. So we get I will be E over R plus R. Questions about that, let me know. But that's it. Let's do one more. So let's say you have this. I want to solve for R. Now there's a trick here we can use. It's called cross multiplication. We can rewrite this as S over 1 equals C over 1 minus R. And cross multiplication says this. If we have A over B equals C over D, this is the same as saying A times D equals B times C. Multiply these two, set that equal to the product of these two. So that means for our problem, S times 1 minus R equals 1 times C. Or we can distribute this S here. We'll get S minus S times R equals C. Now we got to solve for R, and since we got R out of this denominator, it's going to be much easier. So let's subtract S from both sides. Minus S times R equals C minus S. Finally, divide by negative S. Because negative S times R, well, the opposite of that is dividing by negative S. Now, it's a convention in mathematics that we try to avoid negatives like this in the denominator. So what we can do, we can multiply bottom and top by -1. So negative times negative is positive. I'm multiplying -1 still on top. Distribute this -1, and we'll get R is -C plus S over S. -1 times C is -C. -1 times -S is positive S. Or we can rewrite it a little smoother as S minus C over S. And there you go. And there's other approaches to that problem as well. There's a couple ways you can solve that one. All right, let me do one more. Here we're going to solve for H. Well, first off, we want to recover H. That means we want to get as much stuff away from H as we can. There's H's here. We're going to have to work with those somehow. But this doesn't have any H's in it at all, so we can just get it out of the way. So let's subtract 2LW from both sides. All right, so there's less clutter on the side that H is on. That's what we want. We want to get H ultimately by itself. Now, these two terms contain an H, so we can factor out H. Now, we have this entire piece multiplied to H. So the opposite of multiplying that entire piece is dividing that entire piece. Now, we got to be careful here when we divide. When we subtract or add something to both sides, we're just subtracting or adding that one term to both sides. But we're doing it to the sides. So as much as it looks like I'm writing this, like I'm subtracting this just from this term, what I'm actually doing is subtracting it from the entire side. And the only term it's going to cancel with is that term there. And I'm actually subtracting this from the entire side that contains A. So even though on this right side, this is the term that cancels, I'm actually subtracting this from the entire side. And I'm subtracting this from the entire side. Why am I telling you this? Well, when we divide, I'm dividing this entire side by that piece. And what I do to one side, I have to do to the other entire side. I'm dividing the entire side by this one piece. I'm not dividing just the A or just 2LW. I'm dividing the entire side by that one piece. So that means the entire side is divided by 2L plus W. And that gives us H. So that's it for now. If you have any questions, let me know. I might do some other problems in the future. I hope I get some questions, though. I can try to help you with those. But let me know. And other than that, have a wonderful evening.